All right, we're about to pull back the curtain on large language models. We're going to ask a really critical question. When you share a secret with an AI, where does it actually go? Let's get into it. It seems like a simple question, but the answer, well, it gets right to the core of how these incredibly powerful tools actually work. It's all about trust, technology, and the kind of surprising ways our data can hang around long after we've closed that chat window. So it all starts with a really simple action, right? You give the model some input. We do this all the time without a second thought, but what happens next is what really matters. Let's look at a few common examples. Just think about how you might use these tools. Maybe you're a developer, you're trying to debug something, and you paste a code snippet that has a private API key in it. Or maybe you're a manager, and you use an LLM to quickly summarize a long, confidential email thread. Or, hey, you could just be asking a really sensitive question about a personal health issue. In that one moment, a piece of your private data has just been shared. Okay, so what is actually happening under the hood? Let's dig into the mechanics of how these models learn, because this is the stage where our private data can get all mixed up in the training process. At a high level, it looks something like this. First, a ton of data gets ingested. We're talking terabytes of data from the internet, and maybe even from user chats like yours. Then the model gets to work recognizing patterns. It adjusts literally billions of internal connections, these things called weights, to get better and better at predicting the next word. The whole point is to generate useful, human-like text. But it's right here, in this process of tweaking billions of parameters, that a really critical side effect can pop up. The model doesn't just learn. Sometimes it memorizes. This gets right to the heart of the whole issue. The goal, what we want, is generalization. We want to teach the model the idea of a sonnet, so it can write new ones. The danger is memorization. That's where it doesn't learn the concept, it just stores one specific sonnet and can spit it back out, word for word. So here's the crucial point. Memorization isn't really a bug. It's just an extreme form of learning. See, if a piece of data is really unique, or if it gets repeated over and over again in the training set, the model might figure out that the easiest way to be correct is to just store that data point, verbatim. Now, that's fine for, say, a famous quote, but it becomes a massive liability when that data is someone's social security number or a private API key. And this brings us to the real-world consequences. These little pieces of memorized private data, they're like digital ghosts in the code, just waiting for the right prompt to bring them out. And the privacy implications are serious. And listen, these aren't just hypotheticals. Researchers have shown that there are several ways to exploit this memorized data. You've got data extraction attacks, which we'll look at in a second. There's also something called membership inference. That's basically like asking the model, hey, was my data in your training set? And there are even attempts to reconstruct parts of the original training data itself. I absolutely love this quote. It just captures the problem perfectly. We like to think of an LLM as this compressed, blurry JPEG of its training data, right? A general summary. But if a specific piece of data, like your email address or a password, gets memorized, then that little part of the image isn't blurry at all. It's perfect, it's lossless, and it's ready to be read by anyone who asks the right question. And this is exactly how an attacker can get that information. They don't need to hack a server, they just need to chat with the model. By crafting these really specific, clever prompts, they can essentially trip the model into coughing up that exact memorized private data. So for example, an attacker might find a really unique sentence from a public GitHub project, feed it to the model, and then ask it to continue, hoping it just regurgitates the private code that came next. Okay, so that might all sound a little bleak, but the good news is that researchers are already on it, developing some really powerful defenses. Let's take a look at how we can actually fortify these models against these kinds of attacks. And this is the key insight right here. We don't want to make the model dumber, right? We don't want to make it less useful. The goal is much more surgical than that. We want to keep its amazing ability to generalize while teaching it to forget the specific, verbatim details that pose a privacy risk. One of the most powerful tools we have for this is called differential privacy. The best way to think about it is like this. Imagine you're tuning an old radio. You add just enough static, what we call noise, to the training data. The model can still hear the music, it gets the big picture, the overall trends, but it can't make out any of the individual quiet conversations happening in the background. It's a way to get a mathematical guarantee that no one can ever be sure if your specific data was ever part of the training set to begin with. Another really cool approach is federated learning. This one tackles the problem right at the source. So instead of sending your raw data to some central server, a smaller version of the model is trained right there on your device. Only the generalized learnings, those updated weights we talked about, are sent back to the main server. Your private email literally never leaves your phone. But of course, there's no silver bullet here. As you can see, techniques like differential privacy can sometimes hurt the model's accuracy a little bit, because all that noise can obscure some useful patterns. Federated learning is amazing, but it requires a really complex infrastructure to pull off. And even simpler things, like just trying to scrub out personal info before training, well, that can be pretty hit or miss. So choosing the right strategy is always a balancing act between privacy, performance, and just plain practicality.
So, all of this leads us to this fundamental challenge at the very heart of building intelligent systems. You could call it the privacy paradox.
Think about it. The very thing that makes these models so powerful, their unbelievable ability to absorb, process, and recall information, is the exact same thing that creates this massive privacy risk. The better a model gets at remembering, the more careful we have to be about what it remembers. And that leaves us with this final, really critical question. As these models become our co-pilots for coding, our writing assistants, our gateways to information, are we walking into a future where the line between public knowledge and private data just gets permanently blurred? It's a huge question, and it's one that developers, researchers, and really all of us are going to have to answer together.